Now we will look at the machine learning model, the face mask detection program. This has been coded in Python, and the following libraries have been used. We've used OpenCV2, which is a library for computer vision and image processing. Then the library Keras has been used, which is a machine learning library. And then the library Immutals has been used, which is used for video streaming and capturing of images from a given video stream. And at last we used the library Serial, which is essentially for communicating with the Arduino board. So we initialize the variable Arduino using the serial function, and here we define the port to which the Arduino is connected and the baud rate of the Arduino. And now let us look at the face mask detection program. So initially we obtain the image from the frame. We convert that image into a tensor, and then we run it through the face mask detection program to detect the number of faces. This detection is done using the OpenCV library. So once the faces are detected, we loop over a certain range, and essentially we first target a box which basically restricts the frame to the face, and then we make sure that the bounding boxes fall within the dimension of the frame, so that the complete face is actually in the frame. And then we extract the region of interest and then convert it in from BGR to RGB, and basically it is an array now. So here is where we convert it into an array, and after it is converted into an array, we run it through the model here. And if the person is wearing the mask, it will return a positive value. And here in this part of this code is the obtaining of the video stream. So here we start the video stream, of frame is obtained, and then it is fed back into the detect and predict mask function. And then if the label has a mask, if the output mask is returned, then it is printed access granted, and the Arduino code gives out a value 1. So basically through the serial communication, a string of 1 is encoded and sent to the Arduino board for the Arduino board to process. In case this label mask wasn't processed, then we get a print of access denied, and using the serial communicator, the Arduino receives a string 0, which is encoded.
Hey everyone, my name is Shreyansh. Now let's dive into the Arduino code. So we have first included the Liquid Crystal library, which is responsible for printing out the output on our LCD screen. Now we have initialized a variable called it inByte, and then we have also initialized an object, Liquid Crystal object, which we name as LCD, and here are the parameters, which are the pin numbers on our Arduino board according to our circuit. The first parameter corresponds to the RS pin, the second corresponds to the enable pin, and the last 4 are for the registers. Now comes to our setup. So we have first initialized the LED pin as an output. Then we have the serial.begin, which starts a serial communication between the Arduino board so that it can send commands via USB. Then we have this LCD initialized and its dimension set as 16:2. Then comes our main loop, in which we have this function called brightness. After this function brightness, if the serial monitor is available, inByte variable is assigned a value through this function called serial.read. Now if the value assigned to it is 1, then the LED brightness is set to low, and the LCD prints access granted. Otherwise, if the inByte variable is assigned a value 0, then the LED prints then the LED shows high brightness, and the LCD prints access denied. We have not included the code for our buzzer to sound, but its output has been connected with the LED source. So whenever the LED brightness is high, it automatically gives the buzzer. It automatically makes the buzzer to sound, and that's it. Now let's compile the code and check. So compilation is complete without any errors.